Hi there, and welcome back to MA 211. Today we're talking about calculating Laplace transforms. So, this one says, from the definition of Laplace transform, calculate the Laplace transform of e to the negative 6t. Remember that what you should get is a new function whose independent variable is s. So, by definition, the Laplace transform of e to the negative 6t is the integral from 0 to infinity e to the negative 6t times e to the negative st dt. This one is fairly straightforward. I should combine that base and see this is the integral from 0 to infinity e to the negative t times, what is that, s plus 6 at that point, dt. I can calculate that integral without much trouble. Remember, this is a dt integral, so this s plus 6, that's a constant sitting there. So the integral will be negative 1 over s plus 6 times e to the negative t times s plus 6, evaluated at 0 and infinity. And again, you should think of this as, this is a limit. Okay. So what happens to this integral as I let t go to positive infinity? Let's write it out. So this is a limit as t goes to positive infinity of negative 1 over s plus 6 times e to the negative t times s plus 6 minus, and then I can just plug in t equals 0 and I get negative 1 over s plus 6. Okay. So we have to worry about this limit part right here. We need this limit to converge to something. We don't want it to run off and become infinity. In order for this to converge, you would need this exponent to be negative, which means you need the s plus 6 needs to be positive. So s needs to be bigger than negative 6 in order for this integral to converge. If s is bigger than negative 6, then this term will converge to 0, and you'll have a 0 minus negative 1 over s plus 6. You'll get 1 over s plus 6 out of this. So this Laplace transform is defined. It has a value for all s's bigger than negative 6. For all other s's, this Laplace transform is not defined. Alright, let's try another one. So this time, the function I want to transform is piecewise defined. So I'm going to have to break my region of integration into two parts. So by definition, the Laplace transform of f is the integral from 0 to infinity e to the negative st times f of t dt. My f of t is defined differently on these two different regions. There's a different expression for it on these two different regions. So I'll break up my integral into two separate integrals, one on each region. So I'll have the integral from 0 to 4 e to the negative st f of t dt plus the integral from 4 to infinity e to the negative st f of t dt. Alright, so let's see, on the interval 0 to 4 my f of t is 2t, and on the interval 4 to infinity my f of t is 0. So this is the integral from 0 to 4 e to the negative st times 2t dt plus the integral from 4 to infinity e to the negative st times 0 dt, and this integral goes away, this one's 0, so I get the integral from 0 to 4 e to the negative st times 2t dt. And I'll go ahead and factor that 2 out, and now I just have to do integration by parts. Just have to make sure to keep my negative signs straight. There are going to be a lot of negative signs going around. I've got to keep them all in place. So what is this? This is 2 times, now I need to integrate e to the negative st times t from 0 to 4. So this one is the one I want to differentiate, that's my v. This is the one I want to integrate, that's du. So I'll integrate this, get negative 1 over s e to the negative st times my v, which is t. I have to evaluate at 0 and 4, minus the integral from 0 to 4. Again, I integrate this one, negative 1 over s e to the negative st times the derivative of that one, so that's 1. That's a dt integral. Okay, so where do I go after this? Well, this is 2 times. I evaluate this one at 4. I get negative 4 over s times e to the negative 4s. Minus, when I plug in t equals 0, I get 0. So minus 0. Now, what do I have? I have a plus 1 over s from these two. You know, I pulled that out. It's right there. Now I have to integrate e to the negative st from 0 to 4. So I can do that. The integral of e to the negative st is negative 1 over s e to the negative st. I'm integrating from 0 to 4. Alright, so that is 2 times negative 4 over s e to the negative st. And when I plug everything in, I'll have a plus 1 over s times, let's see, I'll have negative 1 over s e to the negative 4s. And now I have to subtract off what I get when I plug in 0, so that's a plus 1 over s. Now I have to just go ahead and expand everything out, make it look nice. So this is negative 8 over s e to the negative st. And then I'll have a minus sign, minus 2 over s squared e to the negative 4s. Oops, that's a 4 here. And that's a negative 4s. And then you'll be left with a what? Plus 2 over s squared. And that's it. That's the Laplace transform you're looking for. Once again, it's a new function with independent variable s. So let's try one more. We need the Laplace transform of t squared. Laplace transform of t squared, by definition, again, that's the integral from 0 to infinity, e to the negative st times t squared dt. This one I want to do integration by parts again. I'm going to need to do it twice. Whenever you're calculating Laplace transforms by hand from this integral definition, pretty common to need to do integration by parts. But it's doable. So this is the one I want to differentiate. That's my v. That one I can integrate to u. So this is negative 1 over s e to the negative st t squared, evaluated at 0 and infinity, minus the integral from 0 to infinity, negative 1 over s e to the negative st times 2t dt. Once again, if s is a positive number, then as this limit goes to infinity, I'll get a 0. So if s is bigger than 0, I'll have a 0 minus. When I plug in 0 for t, I get 0. And I'll have a plus 1 over s integral from 0 to infinity, e to the negative st times t, and let's call this a 2 instead of a 1, dt. Okay, now I need to do that integral. Once again, I need to do integration by parts. This one I want to differentiate. That one I want to integrate. So I end up with 2 over s, negative 1 over s, e to the negative st times t, evaluated at 0 and infinity, minus this integral from 0 to infinity, negative 1 over s, e to the negative st times 1 dt. And just like before, as long as s is positive, this limit as t goes to positive infinity is going to be 0. So I'll have a 2 over s. I'll have 0 minus 0 plus 1 over s, the integral from 0 to infinity, e to the negative st dt. So that's 2 over s squared times that integral is negative 1 over s e to the negative st, evaluated at 0 and infinity. And again, as long as s is positive, the limit as t goes to infinity will turn into 0. So that'll be a 2 over s squared times 0 minus, when I plug in t equals 0, I'll get a negative 1 over s. So that'll be 2 over s cubed. And that's the Laplace transform I'm looking for. Alright, when we say using a table of Laplace transforms, I just mean use the table of Laplace transforms that I gave you. Turn this Laplace transform into a few simpler Laplace transforms that you can look up in the table of Laplace transforms. That table is posted on Moodle. It says table of Laplace transforms. So we know that this Laplace transform, we know that this is linear. So this is the Laplace transform of 6t squared plus the Laplace transform of 4t. Okay, and that's the same thing as 6 times the Laplace transform of t squared plus 4 times the Laplace transform of t. The Laplace transform of t squared is in our table. That's 2 over s cubed, and we actually just computed it. Plus 4 times the Laplace transform of t, that's also in our table. That's 1 over s squared. And that's it. So we end up with 12 over s cubed plus 4 over s squared. Alright, let's just do one more. These are all pretty darn similar. So this is the same thing. This is the Laplace transform of e to the 4t plus the Laplace transform of negative sine 5t. This negative 1 can come out of the Laplace transform, so that's the Laplace transform of e to the 4t minus the Laplace transform of sine 5t. And those Laplace transforms are also sitting on the table. This is 1 over s minus 4. And in order for that to be defined, s has to be bigger than 4. Minus the Laplace transform of sine 5t is 5 over s squared plus 25. And that's it. So this is our Laplace transform. And again, you should really be saying for what values of s is this Laplace transform defined. And that's it.